Reminder that this green note card, so we're on to green in our going through the rainbow of colors of paper. This green note card is what you get to use on your test. Go ahead and put your name on it. And then if there is anything else that you would like to add, so any other notes to yourself that you would like to add, feel free to do that. There's a little bit of space over here. And then on the back, there is a problem where it's not going to take up. I'll tell you when we get to the back. There's going to be extra space on the back. Okay, so Unit 3 is basically split up into 3 things plus the inequalities. So graphing, substitution, elimination. So let's talk about graphing first. When we are looking at a graph, if our 2 lines do not cross at all, there is no solutions. If our 2 lines cross 1 time, there is 1 solution. And if our 2 lines are the same line on top of each other, there is an infinite number of solutions. Okay. In 3.1, we graphed when both equations were in slope-intercept form. In 3.2, we did 1 equation in slope-intercept and 1 equation in standard. This is an example of 3.2. On the test, there is 3.1 that you have to do, and then on the choose a method ones, you could choose to do this on the one where 1 is in slope-intercept and 1 is in standard form. So that's why I wanted to put it on here. For y equals negative 2/3 x plus 6, we're going to start at our y-intercept of 6. We're going to graph negative 2/3. So we'll go down 2, right 3, down 2, right 3. Go ahead and connect those. Okay, for our line that is in standard form, you guys had a choice whether you converted or did intercepts method. I think by far and away more people were doing intercepts method. You could convert that if you wanted, so you would subtract x and then divide by negative 2. Most people did intercepts method, so to find the x-intercept, they would do x equals 2, and that one's just already solved out. So I'm going to graph a point on my x-axis at 2. And then to find your y-intercept, you would do your y term, so that negative 2y equals 2. Divided by negative 2, we get y equals negative 1. So we would have a point on my y-axis at negative 1. Okay, so again, on the test, you will not have to do 3.2. It is an option on one of the problems. Okay, and then we can go in and connect those. How many solutions does this graph have? 1. What is my solution? 6, 2. So remember to always write your solution as an ordered pair. 6, 2. Okay, so as far as graphing is concerned, the things on the test that you have to be able to do is graph in slope-intercept form. So if you know how to do 3.1, you will be fine. On the review, there's not any 3.2 problems because you don't need to be able to do 3.2. You need to be able to do 3.1. Great, yeah. Okay, moving on to 3.3. 3.3 is on the test. 3.3 is on the review. It's on the test. So for 3.3, things that we need to remember, solutions are in the double shaded area. Okay, and then we have our table of what symbols we use, and I think this one might be organized in a different order than the one on your notes, so make sure that you do what we're doing right now, not the one from your notes. You shade above a dashed line for a greater than symbol. You shade above a solid line for greater than or equal to. You shade below a dashed line for a less than symbol. You shade below a solid line for less than or equal to. Okay, so for our two equations, I'm going to fill out these blanks and then I'll zoom in. Our first line is y is greater than 2x plus 4. So greater than is going to be a dashed line that we shade above. So dash and above. And then less than or equal to is going to be a solid line we shade below. So solid and below. Any questions about those before we start graphing? Okay, so our first line is y is greater than 2x plus 4. So we're going to start at a y-intercept of 4. My slope is 2, so I go up 2, right 1. I need a bunch more points than that, so I can also go down and to the left. Down to left 1. I'm going to connect those together, but I'm going to do it with a dashed line. And then we need to shade everything above that. Make sure you shade lightly and in one direction, because you're going to have more shading to do here in a second. So that's everything above. I said shade lightly, and then I shaded kind of dark. Okay. Our other line is y is less than or equal to negative 1/3 x minus 4. So I start at my y-intercept of negative 4. And then my slope is negative 1/3. So I go down 1, right 3, down 1, right 3. And then I can also go up 1, left 3 a couple times. Okay, that one needs to be a solid line, and we need a shade below it. So solid line, and below, so here. Wait, what area of the graph are my solutions in? Bottom corner, that double shaded area. Okay, so for solutions and non-solutions, you are listing any 3 ordered pairs. I think on the test it only has you do 2. It would be very suspicious if you had the exact same ordered pairs as someone next to you. Unless it's like 0, 0, and 1, 1. Those are like the common pick ones. But if you have the same random 4, negative 5, that's kind of suspicious. Okay, what is an example of a solution? Negative what? I can't hear you. Negative 3, negative 6 is only in a single shaded area. Do you mean negative 6, negative 3? Okay. Negative 6, negative 3 is a solution. We could do negative 5, negative 4. That's a solution. Okay. What's one more? Negative 7, negative what? Negative 7, negative 6. I agree. Awesome. So, any 3 points in that that double shaded area. Non-solutions are anywhere in the single shaded areas or the non-shaded area. What is a non-solution for this one? 0, 0. Awesome. I agree. What's another non-solution? 1, 1. Guess what? 2, 2. Those are not solutions. Okay. Work smarter, not harder. Any questions right now?
Oh, just how myself.
Thank you. All right, go ahead and flip this over then. There is extra space there if you need to. This would be a good spot if you need to add if you need to add an example. You could fit a whole system there if you wrote small. All right, on the back is where we talk about substitution, elimination, and then having to pick a method. So let's talk about substitution first. So substitution, you are taking something that is x equals or something that is y equals and plugging it in. Make sure if it is x equals, it gets plugged in for an x. If it is y equals, it gets plugged in for a y. So this one right here is x equals 3y plus 2. Where can we plug in that 3y plus 2? X, because it is x equals. Okay, write small on this one. So I'm going to do it like right here. Don't write huge because you might want that space for something else. So 2 open parentheses. I'm plugging in 3y plus 2. And I still have minus 6y equals 8. Okay, any questions about the substituting of substitution? Okay, from there, we are able to distribute. So 2 times 3y is 6y. 2 times 2 is 4. And I still have minus 6y equals 8. What's going to happen to my 6y minus 6y? They're going to cancel out. What do I have left? Positive 4 equals positive 8. Is that true or false? False. What is my answer on this problem? No solution. So if your variables cancel out and you are left with a false statement, you have no solutions. Okay, we intentionally put that on there so you could have an example of a no solution or an infinite solution, but if you need an example of a substitution where you get one solution, take an example from your notes, an assignment, or your review and put it here. So that's why I told you to write small, because now you have all this space that if you want to add another example, you are completely welcome to. Okay? Questions about substitution right now? Hey, let's talk elimination then. So, I have one thing to say about substitution. 3.4, you have to be able to do. 3.5, just like 3.2, it's an option for some of them, but you don't have to be able to do it. Okay, 3.6 and 3.7, solving systems by elimination. Elimination, we are trying to cancel out our x's or our y's. We have choices. Do we want to make 4x and 6x cancel or 5y and 3y? What's the smallest thing that 4 and 6 both go into? 12, okay. What's the smallest thing that 3 and 5 both go into? 15. Do you guys want to make x's cancel or y's cancel? X? Sounds good. Okay, so let's make our x's both be 12 and negative 12. So I'm going to multiply my top equation by 3. I'm going to multiply my bottom equation by negative 2. Because that'll give me a 12x and a negative 12x. So I'm just going to rewrite them both down here. 3 times 4x is 12x. 3 times 5y is 15y. 3 times negative 14 is negative 42. Okay. Bottom equation, negative 2 times 6x is negative 12x. Negative 2 times 3y is negative 6y. Negative 2 times 6 is negative 12. Okay. Any questions about why I multiplied by 3 and negative 2 or how I multiplied by 3 and negative 2? Okay. I'm going to add these together then. What happens to my x's? They eliminate. Okay, 15y plus negative 6y is 9y. Negative 42 plus negative 12 is negative 54. And I can divide both sides by 9. I get y equals -6. Sorry, that took me a second. Any questions thus far? Okay, so then we have to go solve for x. So pay attention to whether you have already solved for x or y. We have already solved for y. So you're going to plug that in for y. So we're going to take that -6, we're going to plug it in for y. So we've got 4x, you can use either original equation, plus 5y equals -14. We're plugging in -6 for y. So 4x plus 5 times -6 equals -14. 5 times -6 is -30, so 4x minus 30 equals -14. We add 30 to both sides. 4x equals -14 plus 30, which is 16. And then we divide both sides by 4. We get x equals 4. So that is 4, -6. All right, any questions? Hey, last thing we have on here is just a little pick a method situation. These are literally problems from the assignment you guys did yesterday. When we have, actually, let's do it this way. Which of these is going to be easiest to graph? The middle one. They're both slope-intercept form, and anytime you see fractions that are slopes, you're going to want to graph those. So this one would be easiest to use graphing on. Okay, substitution. In order to substitute something, you have to have an x equals or a y equals. Which one has an x equals or a y equals? What? The one on the right, the third one, yes. So this one would be easiest to use substitution with. I do want to point something out. If you want to, so you have another half an example of substitution, circle 2x plus 8. Where could you substitute 2x plus 8 in? For y, because it's y equals. Okay, so if you want to just do those little circles, so you have another little partial example. Okay, and then anytime you've got x's, y's, and numbers lined up, that is best to do with elimination. Hey, recap things that you have to be able to do on your test. 3.1. I should put this down. Things that you have to be able to do on your test are 3.1, 3.3, 3.4, 3.6, and 3.7. So these two graphing sections, this one substitution section, and this elimination section. Things that you can do on your test, so there's some problems where you can choose a method, and you could choose to use the method from 3.5 or 3.2. I wrote that in the wrong order. So just FYI, those are your can-dos and your have-to-dos. So if you want to write that down, I just wanted to tell you, okay? So if you are trying to get caught up and it's a better idea to work on catching up on these things than these things, because these things aren't required on your test. Okay, I think that's it. I'm going to go ahead and stop this video.